This conference will now be recorded.
Hello and hi everyone. A warm good evening to all of you.
Hi, Zafar.
Hi Vikas. Hope I'm audible.
Yeah, you are.
Okay, let's get started about the today's session. So yesterday we have completed session 1 and today we will be looking into the session 2 and today we will be discussing on the we will be discussing about the workspaces. We will be discussing about workspaces. So let's go to the syllabus of our course. Shika Cloud Engineer Certification. Let's go there and look at the syllabus which we have and what we are going to discuss today. So if we look here, if we look into the syllabus, we look into the syllabus here, we can clearly see yesterday we have covered these scenarios like up to we have gone to the 7th part, that's the 6th part. Yes, we have discussed these concepts and today we will be discussing about the implementing and maintaining the state, small portion of implementing and maintaining the state at the backend configuration, and also we'll be discussing about workspaces, how to implement the workspaces in the cloud environment. So we have workspaces. Where can we find the syllabus related to workspace? We'll be discussing this part today. We'll be discussing about this, especially this one, using the provisioners, local and remote provisioners. And apart from that, we will be discussing today about workspaces. Where do we find in the syllabus about workspaces? Where can we find the workspace? Read, generate, configuration. Yes, here we have just. So there are two different types of workspaces. Workspaces on the remote backend and workspaces on our local machine and workspaces in the cloud. So different workspaces. So let's start from our basic thing, that's the workspace. We'll be starting from workspaces. That's the basic thing where we are going to start today. So what is this workspace? What is the workspace? So when we work in it, yesterday we have seen how to work as a single user, and we have worked as a single user, and today we have joined into a team. Assume that today we are joining a team, and when we join the team, we are going to have different people there, and each people is going to have their respective workspaces. Each person is going to have their respective workspaces. So that's the basic thing which we need to observe. Each person is going to have their workspaces. What does it mean? It means that anytime the user launches the resources, anytime the user launches the resources, anytime the user launches the resources, those resources are present in his workspace, in his workspace. For example, today we have user 1, he is launching the EC2 machine, and these things are dedicated to his workspace, and we have user 2 and he is launching another EC2 machine and it is dedicated to his workspace. So that's how the workspace means. So workspaces means They are just like a virtual environment where the user can able to perform the activities, where a user can able to perform the activities. They are dedicated to his specific path. So we have, for example, we have user 1 here, and we have user 2. We have user 2, and user 1 is performing launching some resources, and user 2 is performing some resources. Or assume we have the production environment, and we have the testing environment. For production environment, we are using we are using an instance of very large instance of t2.large with a high configuration, and for testing environment we are using the instance of type t2.small. So what does it mean? It means that for testing environment we are going to launch the instance type with t2.small, and for production environment we will launch the instance with t2.large. So when we work with the workspaces, these workspaces can be organized in the Terraform cloud. So when we discuss Terraform cloud, we will be discussing about the workspaces in Terraform cloud. Today we will be discussing about the workspaces in the remote locations, how to configure the workspaces in the remote backend. And when we write the workspaces, when we create the workspace, we are saying that we are having the dev environment, production environment, and the testing environment. So this dev environment would be the workspace name, production environment, that would be the workspace name, and testing environment would be the workspace name. So these would be the workspaces names, and these workspaces are, we need to launch some machines. For example, in the dev environment I need to launch t2.small. In the production environment I need to launch t2.large. In the testing environment I need to launch t2.medium. So we have 3 workspaces, and yesterday we have worked on our local machine, and that workspace is referred as the default workspace. Anytime if you are launching some resources in the Terraform, and those resources are going to be by default in the default workspace. So the default workspace, for example, if I need to launch the instance of type t2.nano, that would be the instance. So here, if we look here in this case, so we are seeing here this is equals to this one. What does it mean? This would be the key and this would be his value. So this would be the key and this would be its value. This is the key and this would be the value. So this is the key and this would be the value. So simply we call these things as the, we can consider them as the key value pairs. Here. So let's get started. Let's create a new folder to get started. Let's create a new folder. Let's come up here and let's add this folder to our code. So before adding this, yesterday we have written the access provider block. Let's use this provider block. Let's only use the provider block as of now. Let's go add the project folder now. Let's add the project folder. And we have the project folder name is, we have created workspaces 1. That's the name of the project folder. Let's select the project folder. Let's create a new file here. Let's do the file name as provider configuration providers.ef and put the providers code. We know how to write this code. So let's save this file, providers case, and let's launch the resource here. So let's click there and let's give the new file, and we will be launching like an EC2 server in different environments. We will be launching the EC2 machine in the different environments. So let's give the file name as myec2.tf, myec2.tf. Let's get started and let's know how to write the code. We know from the previous session. Let's get the code there. To small portion of the code. So let's get this code from the previous session. Let's get the AMI ID. So let's get this one and put it in our code. And now we need to launch the workspaces. Okay, yesterday what we have done is we have simply gone there and write the instance type, instance underscore type is equals to some t2 dot small. So when we do that, that's the instance type would be the present in the default workspace. The instance type has been present in the default workspace. But now what we are saying today, we will be moving into some advanced concept, like we will be moving into different workspaces. So therefore, instance underscore type is equals to instance underscore type is equals to. So here we need to introduce a function, that's the lookup function. So let's come to lookup function in Terraform. So why only you need to use the lookup function? So that would be the question first which arises. So before that, let's discuss the functions. We will have a separate session on the functions and variables. As of today, just I am giving introduction to lookup function. So what this lookup function is going to do, it retrieves a single element from a map. It retrieves a single element from a map, and it is going to give the value. It is going to retrieve a single element from a map from the key, and it is going to give the respective value. So to experiment this one, we can go to the Terraform, we can go to the console of the Terraform and we can experiment this one. So before that, let's have a look at here. So lookup function, if we look into the example, let's come up here. So a is equals to ay. What does it mean? A is the key and ay is the value. A is the key and ay is the its respective value. So here b is the key and be is the value. So what does it mean? So if we look here, we have a variable type, that's the map. So use some, let's look at the map variable. So what this variable map is going to take. So if we let's understand the syntax for map variable. So variable name map. Let's use some name like my variable map. That's the syntax for declaring the map variable. And what is the type of this variable? It is map. So if it is type is equals to map, and we have different types of variables. For example, we will be discussing them in the variable section. As of now, let's understand in the basic thing. So if we are declaring a variable of type string, then type is equals to string. If the variable of type list, then type is equals to list. In our case, we are using the type is equals to map. So map means it is going to take the key values. It is going to take the key value pairs. So it is going to take the key and respective value. Key and respective value. Key and respective value. And we have started here, and we need to close the map. And it is have the syntax like we need to open the brace here, default is equals to, open it here and close it here. So that's the syntax for the variable map. And if we look into the syntax of the variable map, let's look there. So before discussing about the lookup function, we need to discuss about the map variable Terraform. Go there, and if we look here, variable name, any name, variable name, and type is equals to map. If you look here, syntax default is equals to, we have opened here, and this is the key and this is the value. So this is the key and this is the value. And the same way, in the same way, we have another variable here. If you look here, variable name, this is the list. It is going to take a list of values. It is going to take list of values. Will be have a separate session about variables. Just for introduction, we will be looking into them. So if you look here, this is the syntax for the map variable. So this is the key. What does it mean? So this is the key and look its respective value, fetch the value. So look at the key and fetch its respective value. So that's the map variable, and this map variable can be used in the lookup function. So map variable can be used in the lookup function. So lookup function takes two arguments. First one is the map, and the second one would be the key, map key. Third argument would be the default one, but it's not needed. We look into the lookup function here. Is going to take the map, and second one would be the key. If we look here, we are passing the map here. If we look here, so this is the map. So the first argument till this part, this is the map, and this is the key. Okay. And if you look here, it is returning AY. What does it mean? So fetch the, look into the key and give its value. So A. So we are passing the key here, and it is going to return its value. So in the second example, if we look here, we are passing the key. This is the map. So this is the map, and here we are passing the key here. We are passing the key, but if you look here, we are retrieving the value. But this key which we are passing in the second case does not have the value from the map. See here, whether there is C here, C is present there in the map. So this is the map. That's the first argument. So let's have a look here. So lookup function takes two arguments. One is the map. We know map means it is going to have the key and value pair. And what is the second argument? That's the key. For example, if you are declaring like, for example, if you are declaring user 1 is equals to Kiran. So what is key here? User 1. And what its value? Kiran. So if that's how it is going to work. So key and value. So lookup function takes first argument would be the map, and second argument would be the key. So let's come up here. Instance underscore type is equals to, let's leave the blank. As of now. I'm leaving it. That's because we'll be looking into instance type, how to fetch the instance type. So the first thing is we are discussing about the workspaces. We are discussing about the workspaces. And to discuss the workspaces, we need to have different workspaces. For example, if the workspace is default, by default, every account is going to have the default workspace. I need to launch some t2.small instance. If the workspace is dev environment, I need to launch the t2.media. So in this case, if you look here, so this is the key and this is the value. What does it mean? It would be we need to declare a variable of type map. To demonstrate the workspaces, we need a map now. So let's declare a map variable. Let's come up here and let's create the new file. With the name I like to give as variables.tf, and let's create the variable there. Variable. How do you declare a variable? The syntax is variable followed by the name of the variable. Let's write the code myself. Variable followed by the name of the variable. I would like to give the variable name as my mappy. That's the name of the variable. Variable name. That's the name of the variable. And so if we look into the variable syntax for the map, we look into the variable syntax for the map. Let's go there. Look here. So look at the syntax for the map. So variable name type is equals to map, then followed by default is equals to key value pair. The same thing we need to write here. Variable name, and type of the variable is map. Type is equals to map. Should be enclosed in double quotes. Type is equals to map, and default is equals to if we look into the syntax, default is equals to, just he has opened the curly brace there and he is closing here. In between there, what he is writing? He is writing the key value pair. So in the same way, let's come up here and write the key value pair there. Default is equals to, just we need to open there. Let's close. Let's write the key value pair. So if the workspace is default, I need to go with the instance type as t2.small. So that's this is the key now, and this is the value. And if the workspace is dev environment, I need to use the t2.medium. I need to go with the t2.medium, and if the workspace is testing environment, I need to go with the t2.nano instance type, and if the workspace is production environment, I need to go with the instance type as t2.large. Okay, that's the key value pair. Why we are declaring the variable here? Why we are declaring this map variable? Because we are discussing the workspaces, and that's the reason why we have declaring the key value pairs here. Let's save this file. Okay. So variable name type is equals to map, and default is equals to. Okay, that's good. Let's come up here to the code and instance type. Yesterday what we did like just like we have seen t2.small. Okay, it is going to launch the instance, but today we don't want to get the instance type here for the default workspace, but we need to fetch the instance type dynamically. How do you do that? How do we do the instance type to be fetched here? Just using the lookup function. Let's use the lookup function. And what does the lookup function do? Just now we have discussed. What does the lookup function do? Lookup function, first argument is map, second argument is key. Leave the default one. So map, it is going to take the first argument as the map. So we have the map now. We have declared map. And the second argument, what it is going to take? It is going to take the key. That's all. So what it is going to do now? If the key is found, it is going to return the value of the. Key. So let's come up here and write the code. That's the reason I am using lookup here. Lookup function. First argument is map. Now in the example code, if you look here, if we look at the usage for the lookup function, if we look here, he has declared the entire map, lookup followed by the entire map, key value pair. And if we look into our code, we have the map here, and we need to copy this entire thing, and we need to paste it in the lookup function. That's not the good idea. Now simply what we can do, we can call the variable here lookup. Just call the variable name var dot name of the variable. What is the name of the variable which you have given? look here, variables.tf. Let's rename this file in a good way. We don't want to do the variable name. Let's do the good name there. My variable, my map.tf. Okay, let's come up here and give the variable name. Where dot, what is the name of the variable name which we have created? My map, that's the variable name. Variable name, where dot name of the variable which we have vendor. Where dot name of the variable. And the second argument which we need to pass. Look here. If we look into the code, if we look here, we need to pass the key. For example, if I pass the key here, like what would be the key if you like to pass from the map, go to there. And if I pass the dev, here, if I pass the dev key, comma dev, if I pass dev here, what it is going to do, look at the example from, let's look at the example. If we pass the key here, it is going to retrieve the value. So when we pass dev here, so what is the expected output now? We look into the my where, we look into the dev, then the instance type would be t2.medium. But when we work with the workspaces, the second argument should be Terraform dot workspace. That's the fixed value. Terraform dot workspace, that's the fixed key. Terraform dot workspace, we need to give the Terraform dot workspace because we are working with the workspaces. So that's how we need to do that. Let's come up here. Don't do dev there. Then do the dev environment. Let's do the Terraform dot workspace. Terraform dot workspace. So we have passed the key value pairs for the instance type, and let's close the instance now. Let's close there and let's save this file.
Zafar, what's this Terraform.workspace? Can you explain once again?
Okay. So when we work with the workspaces, the second argument would be the, just now we have discussed on lookup function, right? So
Yes,
when we
right.
look into the lookup function, the first argument is map and
Yep.
the second argument is key. So
Yes.
when we pass the key here, like if you pass dev, and it is going to fetch the dev environment value, key value. But here, when we are working with the workspaces, the second key in the, when you configure the workspaces, so the key would be the Terraform dot workspace. That's the key here. Terraform dot workspace is going to dynamically fetch the key. That's the key. It is going to recognize when you create the workspaces, it is going to recognize the key as Terraform dot workspace. Okay.
Okay.
When we create the workspaces, it is going to recognize this one.
Yeah, can you please go to the code, Jafar, again? Can we just see that code, how you have defined it from in the mymap.tf and in my EC2?
Lookup where dot my map. So this is the, sorry. So the variable should not be not tf. The name of the variable should be renamed to tf. Let's rename the file mymap.tf. That's the name of the file.
Dot .tf was this thing. Dot .tf was is the extension. That's what you're saying.
Yes, it's the variable. So variables are going to have dot .tf was extension.
Okay, and here you have mentioned variable name as my map pi, right? Can you go into my ec2 tf? Do we
Yes.
have to call this section,
Yes.
right? If we call this section, we have to my map.
Where dot name of the variable my map.
Yeah. Yeah, this should be that. Then this Terraform.workspace, we have not defined it, but it should go and by default check that. From this, it is taking it.
Yes, by default it is going to check. How it is going to check means when we create the workspaces, we need to create the workspaces now. When we create the workspaces, it is going to check the default key. Okay.
Okay.
How it is going to check the default key?
Yes, by default it would be the default workspace. We are in the workspaces one folder. Let's come up here. So that's the new folder. So what we need to do, the first thing which we need to do is it's the new project folder. First thing which we need to do is we need to initialize the provider there because it is going to download the respective provider. So let's go to the folder and look there. It is going to download the respective providers. Okay, it has downloaded. Let's come up here.
Jaffer, I joined a bit late, Jaffer. So we started with the workspaces today.
Yes, we have started with the workspaces.
Sure, Jaffer. Thank you.
Okay, it has installed the initialization. So now the question is, how do we list the workspaces? So if you come up here, Terraform, let's list the workspaces. If you don't know, simply we go for Terraform and the workspace h-h workspace help, go for -help. We can able to view the commands, or let's show the workspaces now. Terraform workspace show. So as we discussed, we are going to have the default workspace. As we have discussed, an account is going to have the default workspace. Now, if we look into the key value pairs which we have configured, if we look into the key value pairs, so this is the key and this is the respective value. So this is the key and this is the value. So what this key, it is going to represent the workspace. So let's create the workspace dev now and test and prod. So how to create the workspace? Which command we need to use to create the workspace? So before creating the workspace, when we create the new workspace, the workspace is going to be created. The workspace is going to be created, and we are going to be present in that workspace. We are going to be present in that workspace. First thing is the workspace is going to be created, and we will be present in that workspace. So let's create a workspace now. Let's create the workspace. Terraform workspace. Terraform workspace followed by the keyword which we need to use, new. Terraform workspace new followed by the workspace name dev. If you look here, wow, we have, if you look here, the workspace is created and we have switched to the dev workspace. What does it mean? Now we are in the dev environment, and anytime if you launch the resource from here, we can able to see the respective instance type now. And before that, if we look into the if there is no tf.state file locally, if you look here, okay, as of now, if you look here, look there, we have created the workspace and its respective Dove folder has been created. In the same way, let's create another workspace. Before creating the workspace, look at the code, and the second workspace is test and the prod. Let's create them. How do we create the workspace? Terraform workspace new followed by the workspace name prod. And okay, we have, so as discussed, when you create the workspace, we are going to be present in the current, the workspace will be created and we are going to shift to that workspace. So in the same way, let's create the another workspace, that's the test workspace. Okay, look at the folders here, we have the prod and we have the test. Okay, we have the folders now, dev workspace, prod workspace, test workspace. Okay, and we have the workspace folder there, and under that we have dev, prod and the testing workspaces. And okay, everything is fine. And let's list the workspaces now. How many workspaces are there? To list the workspaces, we can use Terraform workspace list. Okay, that is going to give the number of workspaces. So we have the 4 workspaces, and the default workspace we didn't created it, that's the default one. And if we look here, we are seeing the asterisk symbol. What does it mean? It represents the current workspace. If we look into the asterisk, means it represents the current workspace. And if I go there and if I give Terraform workspace show command, Terraform workspace show Terraform workspace show is going to give me the current, it is going to give me the workspace, that's the current workspace, that's the test. That's why it is marking the asterisk there. And that's how we can create the workspaces. And if we look here, we have the workspace dev, prod and test. So 3 workspaces are there. And if we come up here and let's do Terraform plan in this workspace, if we give the Terraform plan, we are in the testing environment, and the instance type expected is, for the testing environment, it is the t2.nano. The instance type expected is t2.nano Terraform plan. Okay, let's go to the code. That's due to the spelling mistake issue. Let's come up to the code now.
You have to scroll down basically.
Now it has taken terraform.workspace. Let's save this file, please. An input variable with the name myMappy has not been declared. myMappy. Okay, we didn't see here. We have created the variable myMappy. Variable name as the variable name myMappy, type is equals to map, and the respective values which we have configured there. Look into the error. It is saying that an input variable with the name myMappy has not been declared. This can be called with the myMappy block. I think the file name, that should be, let's rename the file name variables.tf only. tf vars means it is going to have, we need to give the key value pairs. So that's, We'll be discussing tf vars files when we discuss variables. As of now, let's go with the default variable name mymap.tf.
One point here, vars.tf, I think you need to give the name as vars.tf. Then only it recognizes it as a variable file.
So variable var.mymappy, that's the name of the variable. Let's look
And
here.
file name needs to change to mymap.tf. You need to change to vars.tf. Rename the
Usually
file.
file name doesn't matter actually, as long as inside code you're writing as variable and then variable name. File name doesn't matter actually.
Yeah, but in Terraform there are two files. It recognizes the variable. One is vars.tf, tf-vars, both the files. You have to declare variable.
That's only the extensions actually, but the file name, it can be any name as long as inside when you're declaring as variable and then variable name. That
Agree.
reads as a yep.
Yeah, except variables. Anyway, let's see how
Even
it
for
goes.
variables also. Yeah, even for variables also.
Okay.
Okay. We look into the instance type here. We look into the instance type. It is t2.nano. That's the instance type. That's because we have configured the instance type in our map variable. That's the instance type, where if you look here, we are in the testing environment. That's the reason t2.nano. Let's do Terraform apply, and before that, let's add tags to the instances to recognize. So let's come to the code and let's add the tags here.
What was the error? What was the error? How did you fix this one, Jaffer?
Error was just like we have not given the variable name. If we give the variable name as tf.vars, like if we rename this file, we rename the file to tf.vars, then it is should be key values. The value should be saved in another file. The value of the variable should be saved in the another file.
Mm-hmm.
Save this files. Let's launch this instance. Let's do Terraform apply. To look at the state, let's do Terraform apply. So we have, when we look into the plan, we are seeing we can able to clearly see the instance type now. If we do apply now, let's look into the state file, enter a value, yes. So let's look into the state file here. Now yesterday we have seen a single state file. And if we look today, we'll be seeing the multiple state files. We'll be seeing multiple state files. We'll be seeing the multiple state files. Let's look at the state file. So if we look here, let's scroll down. We look here, we can able to see the, okay, it has just locked the state file because it is processing the code there. That's yes, it has launched the resource. Let's look into the state file for this resource. Let's look into the state file for this resource. Yes, and where the state file is present, it is present in the test folder. If you look here, so this state file is now present in the testing environment. So this is the resource which we have launched, and the state file is present in the test environment. And let's move to the another workspace and let's launch the resource there. Let's move to another workspace, Terraform workspace. How do we shift to the workspace, we have learned how to create the workspace, and we have learned how to list the workspace. And if you want to switch to the workspace, we can use select option there, Terraform workspace select. And I would like to go with the production workspace. Let's go there. Let's go to prod workspace. Okay, we have switched to the prod workspace. And if we do Terraform plan here, if we do Terraform plan, and if we look into the code, we look into myec2.df file, my map variable name, production workspace, it should be t2.large. That's the, so this is the key now. This is the workspace, this is the key, and value should be t2.large. Let's come up here and look into the plan key value pair. Let's look the key value pair there. Yeah, it is t2.large. Let's do apply. Let's launch the resource. Let's launch this resource. Let's go to the cloud now. The instances. So this is the first instance which we have launched, and the second instance t2.large, it is going to be ready now. And let's look at the workspaces. Let's look at the tf state file. So this is the tf state file for the testing environment. Look into the production environment. We have the terraform.tf state, and this is the state file associated with this workspace. And if we look into the resources, Terraform state list, it is going to give how many resources we have created. And if we look here, it is giving the only one resource. That's the name of the resource which we have created, ws_instance.myec2. And the question is, these workspaces, now the state files are present in my remote location. Now the state files are present in the remote location, and when we work in local machine, the state files are now present in my local machine. When two developers are interacting now, assume that we have two developers, they are interacting to each other, and they are performing the operations on the same resource. So he is developer 1 and he is developer 2. They are performing operations on the same resource. So what will happen in this case? In this case, we don't know which user is performing which operation, and there will be a lock for the resources. On the resources. Let me open two windows, and if you look here, we go there and go to the desktop, followed by the workspaces.
Workspaces 1.
Okay. Workspaces 1. If I do Terraform plan here, and we have another window, right? So this is one window, and we have the another window. If I do Terraform plan here, and if I go to the another window and do the Terraform plan, we look here. Yes, that's the error. We have the error in the locking state because some other users are performing here. They are performing the operations in the another window, and we don't know when the lock is going to be released. So when we performing the operations in our local machine, so that's the case, and we don't know which user has performed which operation. And if you look here, the terraform.tf state, the process can't be accessed because it has a lock on the file. So now the question is, how do you maintain this issue? How to solve this issue? So to do that, we can able to move these. We can able to maintain the state files. in the remote backend configuration. We can move these state files to the remote backend. As of now, we are just testing the environment, and these state files are present in my local machine. These state files are present in my local machine. Now I need to move these state files to the some remote environment. The state files can be maintained in the Git repository, and the state file can also be maintained in the cloud, in any cloud. That's the any AWS or GCP cloud or any other cloud. The state file can be maintained in the Terraform cloud. So as of now, we will be looking into state file, how to maintain in the AWS in a cloud. In a cloud, we can save the state file in the S3. If you take AWS, we can able to save the state file. We can able to save the state file in the remote location, in a remote location that would called as the remote backend. We call it as the remote backend, and we can able to configure the state file using the S3 service. S3 is the global service, and in S3 we are going to have the buckets, and these buckets are used to store the objects like PDF documents or any some password related data. We can able to store them in the buckets. The maximum size of a single object is 5 TB. That's the maximum size of a single object, and we can create up to 100 buckets in an account. 100 buckets we can create in an account. So that's the, and we are going to configure. If we look here, let's go to the intention now is the state files are present on the local machine. We need to move the state files to the remote machine. So let's look there. Let's come up here and look into Terraform remote backends.
Yeah, Jafar, before we move, I have a couple of questions regarding this workspaces.
Yes.
Yeah, can we go to code? Yeah, so the thing is that we are using only one file, and we are using all these workspaces, right? We have only one ec2.tf. Using that file only, we are deploying the servers in different environment, we can say.
Okay.
Am I correct?
Yes.
Okay. Okay. And that tell me one thing. Now this my ec2.tf, I have it, right? Now I want to run some shell script or Ansible for post provisioning, right? Or I want to add user data. How to do that?
So we can do with the help of the provisioners there. We'll be looking after the session. After remote backends, we'll be going there. Okay. Provisioners.
Okay, provisioner, we are going to look into it, right?
Yeah, provisioners. We'll be looking into them.
Okay. Okay, fine. And then how will manage this terraform.tf state, because this name are same but the directories are different, right?
Yes, the name for the files, if you look here, so that's the default terraform.tf state file and terraform.tf state file, but the directories are different.
Okay, one more thing I have to ask is this terraform.tf state, these both are there, right? And they have defined it prod and test. Now, how can I differentiate them between prod and test, that this belong to prod and this belong to test? In that code, is it mentioned there that this is belong to this?
Just we need to look at here. If we need to look at from the, in the code we didn't mention, but if we look into the workspaces, we can find the respective state file. When users are launching the resources in their respective state, in their respective workspaces, there we can able to find the resources in their respective state files.
No. So in the tf.state we have, right, this tf.state. So can we go to that file and check that in which workspace this belong to, whether it is dev, prod?
Yeah, sure. We can. Okay, let's see. Instance type monitoring and code GPU security user data security type.
No, just search for it, na. Just search for prod, whether it will be there or not. We'll get to know instead of doing it line by line.
It's not present there.
Yeah, but we should do something, right? That this file is belong to this workspace that should be there here. See, let's think about the different way. All
In
right.
that case, we
Now,
can add tags, Siraj. We can add tags here directly.
no, that's right. But tags we will add it. That's not a problem. We'll get to know that. But the workspace should be there without adding tag that should be there. That should be something there to identify this TF file.
Okay.
This lineage is
Shiraj,
something which is
this TF state file present within production folder is actually
right.
for production environment state file.
No, correct. No,
TF state file which is under dev environment. Yeah.
Yeah, I fully agree with you. Now let me give you the use case here. Okay, I have a Jenkins pipeline. Okay, what I do is that I have written some Groovy script, and from there I have just select this production the workspace, and then I'm running that to deploy it and everything. Right now, in the same thing, what I did is I want to do that dev and test also. The same thing in the same pipeline. I have selected multiple values there, and I said that okay. Whenever this I have selected multiple values, then deploy these three instances into dev, test, and prod all these three, right? But the TF state file will be there, right? The TF state file, I have to check that which, like this file is belong to this EC2 instance or this workspace, because I want few outputs of that instance. Let's say I need a instance ID. How can I get the instance ID correctly that this is for only this production workspace instance? How can I get that? I have a three
Yesterday
different.
see here. If you want to get the instance ID, we need to go with the outputs. We can list the outputs there. We
No,
can
we
go
will
to the code.
Yeah,
from which file we will
1 second, Jafar, 1 second, let me answer. Actually, in your Groovy script, you have to mention the workspace name. Then based on that, in your Groovy script, in the Jenkins, you have to mention, then only it will recognize. You're telling that different pipelines, different, right? So in the Groovy script,
right.
you have to mention the workspace name. You are
Okay,
initiating,
but
then
yeah, I
your
understand
output.
that.
Yeah, in my
No,
Groovy
no.
script, like I will mention like workspace, creating the workspace in the Groovy script. From there, I'll initiate. So then these files, these folders, what Jafar is showing us, it will create automatically.
No, that's
Okay.
true. But I go to that absolute path and dev and then prod and test, and from there I have to manage. Right now, let's say that okay, I understand that. But what we'll do is now Jafar will explain us right about this how this
Mhm.
workspace we can move these files to the Git and all those things, right? So
Yeah,
after
yeah,
that, maybe this question will be clear how we are going to
Okay.
define it. That
yeah, yeah. And that is one way. Another way, another easy way is Jafar is discussing like tagging and outputs. That's also we can see once it's going to the remote. Thank you, Jafar.
right.
Sure.
Hey, Shiraz and Naga.
Actually,
Yeah,
every
I'm here
environment will
to.
have different state files.
Sorry.
Sorry, I was talking about every environment will have different state files.
Agree.
That will be more different folders or different backends and all. We cannot have two different state files in the same backend in the same location or in the same direction.
Agree. Same folders in the backend itself, different folders for different workspace. We can put same bucket. In the
In the
same
same
bucket,
bucket we can have multiple, but
multiple.
we need to create multiple folders.
Exactly. Same structure there as well. Same structure in bucket as well.
Correct.
Yeah, we need to follow this absolute path. That's what the answer for this actually. We need to follow the absolute path, whether we are making it on the S3 bucket or Git or anything. the workspace name will be there. What the workspace will be there? Like, let's say that we have an application called Facebook or something like that, right? In that we have an environment dev, QA, UAT stage, prod, and DR, all 5, right? And this dev environment will become a workspace 1, and then dev 2 will become a workspace 2, something like that. We have defined it. So what we need to do is that whenever we are storing this Terraform state file into the S3 bucket, we need to follow the same directories or the naming convention there also. Let's say that we have to call it from Jenkins file from the S3 bucket, then we have to go to S3 bucket, and we have to tell that in the code that go to S3 bucket, and then fetch the Outlook or Facebook dev Terraform state file. That's what we need to do in Groovy.
Okay.
Yeah, probably. I'm not clear whatever you discussed, but I think going forward, Jaffer is going to show remote buckets. Then it will be clear. I'm assuming.
Okay, sure,
Yeah.
sure.
Yeah.
Let's go to remote backends. Let's go there. Let's go to backend type. And if we go to the remote backend configuration, the use is we can move the state file to the remote location. If we look here, we have backends like if we use Azure Cloud, we have Azure RM. We can maintain in Kubernetes cluster. We can maintain in GCP cloud. We can able to maintain the workspaces, or we can configure the state file in the remote backend. In the same way, if we look into the remote backend for the AWS cloud, let's look at the AWS cloud. That's the S3 service. We come up here, and if we look here, we can able to perform the DynamoDB. What does it mean? Before that, if you look here, this is the configuration for backend of the S3 service. Terraform backend type, backend configuration S3, and we need to name the name of the bucket. That's the name of the bucket. What does it mean? We need to create the bucket, and we need to give the name of the bucket here. And if you look here, we need to specify the key. So what is this key? This key is, if we look here, this is the state file. These are the state files which are present here, and the name of the state file is going to be present in the remote location with the name of this key. So that's what key represents here. So what does key represent means? It is going to be in the S3 bucket. The key is going to be name of the state file, and that's all. Let's create the bucket. Buckets are region specific, just like we have seen EC2 AMI instances are in EC2 service is a region specific. So in the same way, buckets are region specific. So that's the region. That's the reason we are specifying the region here. So the first thing requirement is we need to create the bucket. That's the first requirement. So let's go ahead and create the bucket. Let's come up here and let's create a new file. Create a new file. Let's use the file name as mybucket.yf, and let's create the bucket. So we know how to create the resource from yesterday's section. Resource in our case, what is the resource which we are creating? That's the S3 bucket. So AWS underscore S3 underscore bucket. That's the name of the resource, and let's give the name of the bucket as that is recognized by Terraform. That's the new, and let's open here. Let's write the code. So before writing the code, let's look into the Google there. We look here, and if we go to S3 Terraform bucket, S3 Terraform bucket. If we look into the resource for creating the bucket, let's look there. If we look here, what is required and what is not required. Let's look into the service there. Okay. Search for the S3 service. S3. Okay. So if you look here, we can able to find AWS S3 bucket. Resource is also AWS S3 bucket. AWS S3 bucket, that's the resource. And if we look into the code, he's giving some different options here. And the needed is argument references. So that's we need to look arguments what are needed here. We look here, what are the arguments that are needed. Let's have a look at the arguments that are needed. And we create a bucket, what are the arguments that are needed. So these things are optional, grant optional, access control list optional, bucket, name of the bucket optional. Anything that is needed here, tags optional. Anything that is needed, we didn't find anything. Versioning optional, logging optional, ID optional. Let's create the bucket. So resource AWS underscore S3 bucket. Let's give the bucket name. Bucket is equals to, so bucket names are unique. So therefore we need to give a different name for the bucket. Bucket is equals to, I would like to give my bucket, some any unique name. Well, bucket names are unique, and let's give the access control list for the bucket. Access CL, let's make the bucket permission to be provided. Bucket should be assuming that it's the private bucket. Let's use the tags for this bucket. Tags is equals to, let's add some tags to this bucket. Tags name is equals to, let's give some tags like environment. That would be a good name. Environment is equals to dev. Okay, let's save this file. Okay, that's the first requirement to configure the remote backends. Come up here. If you look here, this is the syntax for configuring the remote backend. Why you have created bucket? That's because we need to have the bucket here. We need to give the bucket is equals to name of the bucket. So therefore, let's save this file and let's create the bucket. Save this file and do Terraform.
So you have not mentioned region. So will it take by default or?
No, buckets are region specific. So therefore, we need to mention region. If we don't mention region,
Okay.
Region is equals to, I'm like to create in the US East 1 region. That's the default region. US East 1. Let's save this file and come up to the code, and let's do Terraform plan now. Okay, it's the spelling issue there. AWS underscore S3 bucket. CK.
Yeah.
Okay, let's create the bucket first, and we'll be moving into there. Let's create the bucket. Computed attributes can't be set, but a value was set for the region. Okay. We look into the provider section. We look into the providers.tf. We look into the providers.tf. There we have set the default region there. Let's go to providers.tf. Let's scroll down. We look into the providers.tf file. We have already set the region there, and here it's not needed. Let's come up here. That's the issue there. Let's come up, remove this region. So this file, let's come up and do the Terraform plan. Okay, that's the plan which is showing here. We look into the plan. We are creating the resource AWS_S3 bucket dot new. What is this dot new? That's how Terraform recognize this resource. That's how the Terraform is going to recognize this resource. So let's do the Terraform apply and create this resource.
Jaffer, ACL is mandatory. Jaffer, ACL is not required, right?
ACL is not required. It's not mandatory. Access control lists for the resources is not required.
Sure, Jaffer. Okay.
Let's look into the cloud resources, whether the bucket has present in our cloud. Let's go to services, go to the S3 service, go to S3. And yes, this is the bucket which we have created, and the resource has been created. Let's list the total number of resources there. We list the Terraform state list. We need to look 2 resources. Yes, we have 2 resources. And the thing is, the state file is now present in our local machine. We need to push the state file and the workspaces to the remote location. So that's what we are trying to do. If you look here, that's the backend type we are pushing to the AWS S3 bucket. So Terraform backend type is S3, and we need to specify the bucket name. We have the bucket name is now ready, and the key. What is this key? The key would be the name of the state file. If you give any name here, and that name is going to be present in the S3 bucket, and that name is going to act as the state file, and the state file is going to be present with the name of this key. So let's configure the backend now. Let's use this code and put it in our local machine there.
Can we
Jaffer,
store
can we
this?
move resources from one workspace to another workspace?
Yes, please.
Can we move resources from one workspace to another workspace?
Can we do resources from one workspace to another
Resources
workspace?
from one workspace to another workspace. Yes.
Can we move resources from one workspace to another workspace? Can we
Yes,
move?
correct.
Can we move resources from one workspace to another workspace? Okay, let's do the remote backend. Then we will be testing them. Okay.
Okay.
Okay. There we are. We are in the remote backend file.
So Jaffer, can we store these files, Terraform state files, instead of S3? Can we move it to Git or copy it to Git? Can we do that?
Yes, we can store them in the Git repository.
Okay.
Let's create the file with the backend.tf and put the code here. If we go to the remote backends, and if you look here, if you go to the which one we have asked, we have asked about like the state files can be stored in the GitHub repository. If you look into the standard backends, we have Artifactory, Azure, GCS, HTTP, PG, S3 bucket, Swift. So those are the things that are present, but here they have not listed, but we can able to find directly in search from search. Okay. Let's give the name of the key here, and let's change the bucket name, and the bucket name is, what is the name of the bucket name which we have created? That's the name of the bucket. So this is the name of the buckets. Let's use this bucket name and put it here. Let's come up here and go to the backend.html file, backend file, and put the bucket name and key. I would like to give the state file name in the remote backend as my state file. That's how it is going to save there, and we need to specify the region, backend type, and the bucket index region. Let's save this file. So yesterday's session, we look here, we have discussed that when we do backend, when we change the backend type from, we are on the local backend as of now, we are on the local machine, we are on our local machine. When we do the remote backend configuration, when we do the remote backend configuration, we need to do Terraform init. We need to do again Terraform init. So to initialize the backend, we need to do the Terraform init. So when we do the Terraform init, what will happen? The local resources which are present in our cloud, they are going to be moved to the, the local resources which are present on our local machine, they are going to be moved to the remote location. The state file is going to move to the remote location. So let's do Terraform init there. Terraform init. If you look here, error in configuring the S3 backend, that's because, and if you look here, error in validating the credentials, that's because the access keys and secret keys which we have configuring here, they are present in the providers.tf file. Let's scroll down. They are present in the providers.tf file, and these access keys and secret keys should also be included in the backend.configuration file. So let's come up to the backend.tf file and put the access keys and secret keys in the backend file. Anytime if we are seeing the error that is related to error information that is related to 403, the error would be the access keys and secret keys error. So let's do it now. So if you look here, do you want to migrate all the workspaces to S3? That's what it is asking. And if you look here, Terraform will copy all the workspaces with the same name. This won't overwrite the configurations in the destination file. And when I give yes, so before that, if we look into the cloud, we look into the bucket, we go there. Is there anything here? Nothing is present, right? There is nothing in the bucket. So again, I will show you. Go to S3. So this is the bucket. Let's go to this bucket. Nothing data is present in this bucket. And whenever we do S here, whenever we do S, whenever we give S there, and look at the bucket now. It is going to migrate all the state files to the remote backend. Successfully configure the backend S3, and let's move to the, yes, it is initiating the plugins again. And if we look into the remote backend file, let's refresh this one. Let's refresh the objects there. Go to S3, go to objects, please. Go to S3 service, go to the bucket. Let's refresh the objects there. Yes, we have the env folder. Under that environment folder, what is this env folder? What is this env folder? So this is the workspaces which we have configured, dev, test, and the those are the two workspaces where we have the folders, prod and test. And if we look into the file, let's come back there. We have the prod and its respective state file. Let's go to objects again. Go to the env : folder. we have the test environment there and its respective folder, and if we can able to look the object content here, access denied. Let's make this file access denied. We can able to view the file here, or we can able to view the object there. Let's make this public access so that we can view the contents here. Let's make this public so that we can view the contents in the file. Let's make this public and go to the file there. Let's go there. Look at the state file. Can we view the state file in the remote location now? So if you look here, that's the name of the state file which we have given. So my state file, what does it mean? If we look into the code, that's the key. So this is the key, that's the state file, and that's the name of the key which we have given, and that's how it is going to store here. So this is the object, and if we go to this my state file, and if I click on the object URL, I can able to view the state file in the remote backend. I can able to view the state file. I can able to view the state file in the remote backend configuration. You can able to view the state file associated and its respective resources there. You can able to view in the remote backend. Go to the bucket. Let's move to the bucket, please. And it has created a folder env:/. Under that folder, we have the prod and the test, and this is the file name which we have given